So far we've dealt with adding heat to solids or cooling off solids. Let's look at the solid-liquid phase change. When a solid compound's temperature is at its melting point, an addition of heat energy causes a phase change from solid to liquid. That makes sense. Let's think about ice, and it's close to its melting point. Any extra energy that we put in will cause it to melt into a liquid. When a liquid compound's temperature is at its melting point, a loss of heat energy, removing the kinetic energy from those molecules, can make it change from a liquid to a solid. That also makes sense. The amount of heat energy needed to melt 1 mole of solid, or the amount of heat energy lost needed to freeze 1 mole of a liquid, is calculated using a specific value, the heat of fusion. Now, this fusion has nothing to do with nuclear fusion. Fusion just refers to freezing or melting. Energy is needed to melt a solid. When melting, delta H will be positive. That's helping you with the sign here. When you're freezing something, a liquid freezing, delta H is negative. Energy is released. Here's the equation for dealing with freezing or melting. Delta H here is again change in enthalpy. And anytime we're going between phases of a solid or liquid, the heat energy will be equal to the number of moles multiplied by heat of fusion. H fusion is a specific value that we can look up in a table. So any compound or element will have its own heat of fusion. So let's use the heat of fusion. We're asked to calculate how much heat energy is needed to melt a 6.937 mole sample of ice at 0 degrees Celsius. Now, it's nice that they're giving us an amount of ice in moles, because we would have to convert to moles if we were going to use our heat of fusion. The heat of fusion for ice is 6,008 joules per mole. So for every mole of ice we have, we need 6,008 joules in order to heat it enough to melt that 1 mole. So we're going to use the formula. Delta H, our change in enthalpy, is equal to our heat energy, which we're looking for. That's the amount of moles of a substance we have multiplied by the heat of fusion for that substance. In this case, it's ice. So delta H is going to be equal to the number of moles, 6.937 mole of ice, multiplied by this heat of fusion. Time for the calculator. Delta H is equal to a positive 41,677 joules. So that's how much heat energy needs to be applied. See, that's a lot of heat, 41,000 joules. So sometimes you might be asked to convert to kilojoules. If we were trying to get this into kilojoules, we would just divide by 1,000, 41.7 kilojoules. Again, important to know what amount you're given. If you're given ice in grams, you'll have to convert to moles. The last thing to note about heat of fusion is that there's no temperature change happening. You could put a thermometer into this system, just like we have depicted here. Adding 41,000 joules, in this case, to take a sample of ice at 0 degrees C, to get it to water at 0 degrees C, results in just separating those water molecules enough to go from a solid crystalline structure to liquid water. So that's where the energy is going. So when a solid is melting at its melting point, when the heat is being added, the temperature does not change until the solid has completely melted. When the solid is totally melted and more heat is added, then the liquid will rise in temperature.